to clickmyprojects.com. We are going to see the paper regarding grid service reliability modeling and optimal task scheduling considering fault recovery. So this paper comes under the domain of grid computing. Grid computing means sharing of resources. The resources may be of any form. And then what are the major challenges that is addressed in this grid technology is this scheduling and then load balancing, etc. So this scheduling is considered with respect to fault tolerance mechanism. That is the main concept that is addressed. And then grid, when you're taking this grid technology, it has emerged as an important tool for solving compute intensive problems in scientific industries. Okay, on concerning large scale system, this grid computing is providing a major role over there. Okay, it is going to reduce the task proceeding time, that is processing time, and thus the reliability of grid service is also very optimized. That is, in existing system, many researchers focused on the remote node fault recovery. Remote node means there is two things, one is local node and remote node. Local node means all those task scheduling will be addressed in the same node, whereas in the remote node means it will be addressed in a different system. That is a concept. So grid service reliability is going to address these two things. One is remote node and local node fault recovery. So local node fault recovery means it is going to resume the subtask or any failure under that particular node only. If at all remote node means it will be executed on some other node. That is the difference between these two aspects. See, another thing what we are going to cover in this paper is grid service reliability. So it is nothing but it is the probability of the subtask involved on service which has to be executed successfully. That is the GSR. So there is no concern on what are the sources of failures, but what matter it is whether the end results can be ended to the grid service, that is grid resource management systems or not. That is called as RMS. Okay, so it is all those things are considered in this paper. And while you are going for migration expenses with RNFR and with LNFR, what we are going to consider is the fault recovery, which one will be optimized. So whether the sending this process to this node or other nodes will be minimized or what, that is what we are going to consider. And in the existing system, this GSR was addressed by using the genetic algorithm. Okay, so that algorithm was based on graph theory and Bayesian approach. So these correlated approaches were also developed. But what happened means it resulted in failure correlation among the communication channels. Okay, so that was the major drawback, and also those works did not incorporate the fault recovery, and it didn't include the practical constraints of grid resources on optimization. So these are the things that was not addressed in the existing work. So we are going to rectify all those works and we are going to present an optimized system. Okay, so another thing what we are going to deploy is min-max cost reliability scheduling algorithm. Now we are going to see the flow of this particular paper. We are in need to frame the grid environment initially, and after that we are in need to consider all those subtask creation and splitting, all those things. So everything will be taking care of the server, that is RMS server, and after that all those things will be pooled. Okay, all those tasks and whatever the things that has to be scheduled will be pooled, and after that we will be taking the constraints such as processing time, the length of the task, everything. Then we are in need to evaluate the cost constraints such as processing capacity, link, bandwidth, CPU, memory, disk space, etc. So these constant cost, after mining all those things, hard constraint matrix is constructed. After that, the attributes of each and every node, that is cost constraints, is evaluated and it is congregated with the hard constraint matrix. And finally, grid service reliability cost is obtained, and that will be giving a total cost, and after that minimum cost scheduling algorithm is being proposed for having the better scheduling and then fetching the result after to the appropriate user. That is the overall concept of this paper. Now we are going to see the running procedure of this project. First, you are in need to open this NetBeans and you are in need to coordinate with your net source code, and after that you are in need to start the WAMP server. Okay, and after that you are in need to add the libraries that is being given. Then you are in need to click the subtask.java and start running the code. So process selection is done. You are in need to select these particular files such as P1, P2, P3, P4, either of these files. So I'm just selecting this P2. After the destination select directory, you are need to select the same directory. G reliable. Then open. Yes. Processor received. Then split process. So this is one file is being split out into these these four parts. Arrival time is estimated, and after that, pools are taken up. So this is the task pool. You can just see the task pool. And after that, RM is server executions. So just formation of grid environment for these four tasks, and after that allocation. So this one, each and every task is allocated to each and every resource. So this is the resource ID 13, 9, 17, etc. So this is the processing cost, that is migration cost. And after that, hard constraints matrix is evaluated. So the task and the resource matching is done here, and after that hard constraints matrix are evaluated. So this task is present at R1. Second task is allocated at R3. That is the concept of hard constraint matrix. And after that, the constraints such as failure intensity and all those things are estimated. So the failures are evaluated, and then recovery rate, and recovery constraints, failure recoverable, and then processing capability of these nodes, node 1, node 2, node 3, all those things are estimated. So these are the attributes. Then subtask complexity we are going to evaluate, and its execution time. So based on the approximation basis we have evaluated. And then all these things, further coming things, are based on the failures that are occurred. Hardware failure, software failure, link failure, network failure, and subtask, any subtask probability of failure, and then grid service reliability cost, and then GSR. So total hardware cost, execution, lifetime. So this is these things are as per the algorithm of GSR. Then in this form, two things, that is with recoveries and without recoveries, are considered. So these are the constraints without recoveries, and this is the cost for overall recoveries. Okay, and after that, the total cost for each and every node is calculated, the GSR rate, and heuristic values are obtained. So out of this heuristic value only we are going to have the job complexity also. So how we are going to run this thing means, we are in need to click this process file.java and start running the things. So totally we have just evaluated four things, right? P2, first task is P2, next is P4, next is P1, and next is P3. So in this order it will be executed. So this is the activated task, and this is the execution procedure. It is this node 0, the job 0 is allocated to node 0. Gridlet 0 is nothing but job 0. So this thing is proceeded using Gridsim. And after that, each and everything, the result of each and everything is evaluated, and you can just see the task completion for each and every node. Okay, so in this basis the things are evaluated. So we have just scheduled the grid environment. After that we have evaluated certain cost, and then prioritizing the cost, it is being allocated to the nodes, and certain outputs are evaluated. So this is the function of this particular project. Thank you. Thanks for listening.